Howdy folks, this is actually going to be our last video, which makes me kind of sad, but we're going to follow up on what we learned in the previous video about our G-tests, and we are going to go ahead and run a G-test in SAS Jump. So as you can see over on the right side of my screen, I have my data set up in Excel in the exact way that I would need to set it up for a SAS Jump data set. So let's just go through this again. I have my gender, which is my nominal independent variable, and I have my nominal dependent variable, which is the question, is this person a better long distance runner than they are a sprinter? Okay? And if you look over to our drawing again, I had, what, 9 females who said they were better long distance runners than sprinters, and I coded that with a Y for yes, they're better long distance runners than sprinters. And I've filled that information in Excel. Same thing with females who said no, they're not better long distance runners than sprinters. All 7 of those individuals have been entered into Excel. And I did the same with the males, the 3 males who said they were better long distance runners and the 12 who said they were not. Okay, so how do we use this data in SAS Jump? As always, we're going to open our data table, and I'm going to open Hista G-test, and I'm going to import that information. I'll close that Excel sheet. All right, like always, the first thing we want to do is to make sure that Jump realized that both of these columns were nominal data types. And if we go over here, we see our trusty red histograms, which tell us, yes, they're nominal data types. So we're good with that. All right, next let's go ahead and click on the column header for L greater than S, and that's again for our nominal dependent variable, because I'm interested in seeing if being a better long distance runner depends on gender. So like we did for the logistic regression, I want to go to column properties, value ordering, and then I just want to move Y up in the window because that's the data I'm really interested in, and that's the way I want it to appear in the reports. I want to see that the people who were better long distance runners first, so I'll move that up. This is not essential. This is just how I do it so I can see my data a little more clearly. All right, next thing we're going to do is go to our Analyze platform, and we'll go to our Fit Y by X platform. Okay, so now we know that our gender is our independent variable, and we're trying to see if gender causes an effect in our dependent variable, which is L greater than S question mark. So being a better long distance runner than a sprinter. And as you can see here, I still have that question mark just to show you that we coded it to yes or no. All right, and here's the output that you're very likely to see. So this looks a bit confusing, but don't worry about it. I'll come back to that in a minute because, like with all of our tests, we don't want to start interpreting this figure until we know for a fact that our statistics are significant, until we know that there is or is not a reason to reject our null hypothesis. So the first thing we want to do is to look for our test statistic and our p-value, and that can be found under tests and then further under likelihood ratio. Now, I told you we were doing a t-test, so why am I seeing a chi-square value? Well, don't worry about that. The chi-square is actually the statistic we use in a g-test. It's what we're comparing our values to. So for my g-test, my test statistic, oh my goodness, is chi-square. We have a value of 4.439. But what we're most interested in is the p-value. So again, that's prob greater than chi-square. And we see that our p-value is 0.0351. So what does that tell us? What's our cutoff value for p-values? You should know that by now. It's 0.05. So anything above 0.05, we would accept our null hypothesis. But you can see here that we have a p-value below 0.05. So we reject that null hypothesis, right? And we say that we do see a difference in proportions among genders. All right, so now let's look at the figure. Now that we know that we do have a difference in proportions among genders, let's look at the figure. As you can see on the left-hand side, the y-axis, it goes from 0 to 1. This is basically 0 to 100% because we're looking at proportions. And again, on the x-axis, we have gender, female or male. Not a big deal. So if you focus over here on your right, you'll see a red bar, which represents our answer yes. So individuals who are better long distance runners than sprinters, because we said that was what we represented by Y, that's going to be a red color. The blue is our no answer. So individuals who are better sprinters than long distance runners are represented by this blue color. So what do you notice here? Keep in mind we're interested in this yes, in knowing whether individuals are better long distance runners than sprinters. Well, what I'm seeing is female individuals are better long distance runners while males are better sprinters. So I have a higher proportion of females who are better at long distance running than I do males who are good at long distance running. So what would my results statement look like for this test? Well, let me clear this out really quickly. I'll move this over so we can see the statistics. All right, so my results statement would appear something like this. Oh my. Okay, let me get a different color. That gold is pretty hard to see. I would say female individuals are better long distance runners. Than males. And of course, I would put my test statistic, which was 4.439. And I would put my p-value, which was 0.0351. All right, and that answers my question. Now remember, my question, excuse me, my question was, does gender of an individual influence whether they are better long distance runners? And yes, female individuals, based on our G-test, are better long distance runners than males. Well, I thank you so much for braving through this video series with me. If you have any questions about the statistics or maybe more details about the statistics, because this video series really only scratched the surface. We don't want to make it too complicated. You're going to learn more about statistics in your statistics courses throughout the rest of high school and also in college. But if you want to get more in depth with it, please contact your HISTA coordinator, or also talk to your professors, your teachers at high school, and I'm sure they'd be happy to help you out. Again, thank you so much. Bye.